Hi, everyone. Before I start my talk today, I'm curious, who here works with Rails at work? Okay, most of us, that makes sense. Put your hand up if you work with Rails 8. Oh, cool, okay. Put your hand up if you work on Rails Edge. Yeah, okay. Put your hand up if you work on Rails 7 or below. Okay, well, for everyone here, I'm hoping to convince you with this talk today to upgrade your Rails applications to Rails 8. So with that, I'll get started. Bin Rails server. Many of us have used this command before. The command boots the application and it attaches it to an application server. And this is what many of us associate boot time with. The application server starting up and eventually serving out our app. But it turns out a lot of commands do this. Server, console, routes, test, generate, all of these will boot your application. And we use many of these every day. Some more than others, but when your application is slow to boot, all of a sudden this can become quite painful. And you might be thinking, okay, well, I can just use Spring, right? And Spring is a great gem, but it doesn't make your application boot faster. It makes your application boot less often. When you need to restart your computer, change configuration, update a gem, you'll need to boot the application again. The fact is, as an application grows, boot time often grows with it, which slows down productivity, costs more money, wastes people's time, and diminishes the overall developer experience of your application. And it was slowing down the Shopify monolith as well. Boot time was steadily increasing, people were waiting way too long, and something needed to change. Hi, I'm Gannon. I'll be talking about some development speed optimizations in Rails that I made with my team last year. I'll be talking about file watching optimizations, routing optimizations, and initialization optimizations. But before I do, I want to quickly talk about this command, bin Rails boot. Bin Rails boot was added to Rails in Rails 8.0, and it isolates the booting part of Rails into a singular command. If you run it, it appears to do nothing. It just boots the application and exits. But it has one notable use. You can use it to run a boot time profile. So you'll need a profiler first, though, in order to do that. So I'll be using StackProf, but you can use something like Vernier as well. So you can add StackProf via bundler to your application like this, bundle add StackProf. And if we add this snippet to config environment RB of our application, we should be able to profile boot time. So let's walk through this code. First, we check for a StackProf mode environment variable. And then we take that mode and check for a StackProf interval and default it to 1,000. And then we require StackProf and start it up. Note that StackProf is a sample-based profiler, so the interval is telling us how often StackProf should be collecting data. You don't necessarily need it, but it's nice to tune the amount of data that your profile is collecting. And when the Ruby process is exiting, we stop StackProf, get the data from StackProf, and then write it to a file. And then now we can run bin Rails boot with this StackProf mode environment variable. We're specifying StackProf mode equals wall to denote a wall time profile. And this outputs a file to a Rails application temp directory. Now we need a visualizer in order to use this file. So we can use speedscope. So I'll be doing npm install speedscope here to get speedscope from npm. And you then feed it the profile data file from earlier. And this is what a new Rails application looks like when you do that. And if you're not familiar, this is called a flame graph. The graph has an X and Y axis, and speedscope inverts the Y axis, so the data is top down. The X axis is time, and the Y axis is stack depth. And we graph stack frames in this graph over time. we can segment the graph into two sections here. The first is the application's gems being loaded. The more gems you have, the longer this section will take. Most applications will spend the majority of their time here. The second section is Rails starting up. This is where Rails sets itself up and the initialization process happens. Now, there's plenty to talk about in both sections, but today I'll be focusing on this second part and all the changes in Rails that we needed to make in order to make it faster. Going back to the config environment RB file, we see initially that we have a require line and an initialize line by default. And this reflects the two areas that we saw in our flame graph, the Rails, the gem require section and the Rails setup section. And also, if you were to require this environment file, it will boot the application as a result. So on new Rails applications, this is pretty quick, but on one of the largest Rails applications in the world, not so much. The first thing we noticed that was a little bit slow for us was file watching. We can visualize file watching with a diagram. So we have our developer here. The developer starts a Ruby process. The Ruby process watches a set of files, and the developer then edits those files at some point. And once those edits happen, the Ruby process will detect that the files have changed and then do something. This probably makes you think of autoloading, and we do watch Ruby files in development like this for autoloading purposes, but we also watch other kinds of files too. One of which is translations. Translations live in the config locales directory of your Rails application, and we use the i18n gem to interpolate them into our views and other places. Multilingual applications can have thousands of translations, and gems can also add to the amount of translations that an application has. So the time it takes to sort through these can quickly add up. This is the code that powers locale file watching in Rails. So let's walk through it. First, we grab the configured reloadable directories in Rails. Then we initialize a reloader, passing it the i18n load path and the directories. It's worth noting here that the i18n load path is just a large array of translation files. And when a reload event happens, it executes this block. So we trim inside this block non-existent files from the i18n load path. And then we also make sure that all reloadable paths within the reloadable paths within Rails that exist are present inside the i18n load path. And then finally, we execute a reload. Now, we made a few changes to this code, some of which may or may not be obvious, but if you look at this code under a profiler, all of a sudden things start to make more sense. In an application with about 5,000 translations, we can see that we take about 500 milliseconds to load everything, and that's a fairly long time. So looking at the bottom of the graph, we can see that the majority of time here is spent doing file stat checks, checking whether or not files exist or not. And we, that's not too good. We can do better. Looking a little bit further up the stack, we can also see that we're using the active support evented file update checker, and that the execute method inside of that is to blame. But the active support evented file update checker is not necessarily the problem. It's the block that it's executing here that is the problem. Talking to the file system is a bit expensive in general, especially when we have a lot of those files to iterate through. So let's talk about how we fix the problem. First off, we filter out everything that isn't in the Rails root within our i18n load path. Any translations outside of the i18n or outside of the Rails root are likely not going to change over the development lifecycle. So we can ignore them, and that significantly reduces the amount of files that we need to watch. Then we only delete missing files in the i18n load path if they start with the Rails root. Again, we can probably just leave the ones that are in gems and other places in our system. This avoids a lot of unnecessary file stat checks. If you were to profile this code again, we can see we've significantly reduced the amount of file stat checks that we're doing. So not nearly as many, but there's still some here, so we can do better. We're still executing the file watcher on boot, but maybe we should be asking ourselves, like, why are we doing that? Well, the I2N load path of our application should be clean when the application boots, and if it isn't clean, then, or if there's some kind of redundant data in it, there's probably a bug somewhere else in our application. So if we were to remove that line, all of a sudden we're not doing those checks on startup anymore, and that would make sense because these files shouldn't magically change when the application boots. Bringing the code back under a profiler, we can see a roughly 5x improvement here. So we're down to under 100 milliseconds, about 90 milliseconds. And we're still doing some file I/O in other sections of the code that I didn't show, but yeah, significantly less. You can read more about these optimizations in these two Rails PRs, 52271 and 53259. Better I2N file watching is available in Rails 8.0 onwards. The next thing we noticed that was a little bit slow was Rails routing. And we can visualize that with another diagram. We start with our developer again. The developer makes a request to the application, and then the application responds back to the developer. And when that request happens, it goes all the way up the middleware stack like that, up past the routes to the controller. The controller processes that data and then returns a response back down the routes, back down the middleware stack, and then out of the application as an HTTP response. Now, routes are defined in config routes RB of a Rails application, and this file is evaluated on boot, along with any engine or manually drawn route files. Here we draw a root route, some resource routes, the Rails health check route, and some user routes that are in another file. Now this example here is pretty quick, but on an application with a lot more files, well, it can take quite a long time to draw. And this is what the route loading logic looks like in Rails. And if you're wondering, yes, it is another file watcher. So first we create a routes reloader object. We tell it whether or not the application is eager loading. And then we conduct a execute to load our application's initial set of routes. In an application with about 3,000 routes, we can see we're taking about 460 milliseconds here. And that is, again, not ideal. The bottom of the graph here is obfuscated, but you'll have to trust me when I say it's just drawing a lot of routes and nothing is really unnecessarily slow. It's just doing a lot of work. We know based on the profile that this line is the problem, this execute line, and it isn't really necessarily as easy as removing this line this time. We know that we need our application's routes, but maybe we should be asking ourselves when exactly we need them. Well, we need them whenever the Rails application's route set is touched. And that usually happens when we make a request or we ask the route set for like a route helper, for example. And there are other use cases, but these are the two biggest ones. Generally, anything that touches the Rails route set will need to have those routes loaded. So we need to build a smarter route set, one that knows how to intelligently load itself. And we can do that a few different ways. But we landed on using a subclass and calling that subclass the lazy route set. So when public API is executed, we execute a conditional reload in the method override, and that way we're able to load the application's routes at the latest time possible. In order to conditionally reload, we also need to change the logic of the routes reloader class. We can see in the execute method there we have the loaded Boolean set to true, and the reloader here can detect as a result when the routes have been loaded. And then when we implement this new execute unless loaded method, it will simply check if that loaded Boolean is flipped, and if it is, it won't do anything. And if it isn't, then it will conduct a reload for us. Finally, we update our application's routing setup in order to execute only if the routes aren't lazy. And we do that based on how Rails works with routing under the hood. This is the source code here. The Rails routes for applications and engines are lazily defined. So that means that if Rails gets too close, or rather, if the routes method is defined and called at a certain point in time during initialization, it will like eagerly evaluate that. So some applications also use routes outside of the routing file and draw routes outside of the routing file, but that's usually for testing use cases. But we still need to consider all of these use cases when we're making a patch to Rails. So we try to set the application route set to the lazy route set, but it's really only best effort. It won't work if the routes are drawn too early. In other words, we default to a regular route set, and then if we make it further along in the initialization process, we'll use the lazy route set. It's also worth noting that we only use the lazy route set in development and test, and that is because we need to do as much upfront as possible in production environments. We need to optimize for fast requests and efficient forking. So we only use lazy routes in dev and test environments. Profiling this code again, we can see that, or rather not be able to see that the routes are drawn, and that's great, because we've entirely removed it from the boot process. As long as you don't invoke the routes too early, they won't be drawn in the boot process at all, and they'll be drawn when they're needed later on in the application's lifecycle. You can read more about the lazy route set feature in Rails in this PR, 52353, and this feature is available in Rails 8.0 or later. Finally, we noticed something a little slow about initializers. Most of you have probably used initializers before. Generally, they are pieces of code that are run at boot, and inflections here are a common use case for initializers. Here we tell the active support inflector about the acronym GraphQL. And this way, we're able to use the GraphQL acronym capitalized properly in our application class files without Rails getting confused about file naming. Application initializers are typically file-based, but you can also define them in blocks. And the lazy route set setup here happens in one of those block-based initializers, for example. Block-based initializers are also named and can have constraints. You can specify order using before or after keys, or leave them entirely unordered. This means that Rails needs to sort initializers at some point, and that's done in the initializable collection class. Note that this includes Ruby's tsort module and extends array. Now, tsort is short for topological sort, and topological sorting is a bit complicated. But you can think of it in terms of a graph with nodes and children, hence the definition of tsort each node and tsort each child. Each node is an element in the array, and since we're extending array, we can just alias the each method here. Each child is an element that runs in the array before a node initializer, or any element who is supposed to run after a node initializer. Now, I don't know about you, but that is pretty confusing, so let's look at an example. Let's say we have an initializable collection with 4 elements in it 0 through 3. These will be our nodes in our graph, our t-sorted graph. Each node has children when sorting, so we can keep track of that with arrows, and we're essentially going to turn this array into a directed graph. Each element has implicit ordering, so if an after constraint isn't specified, it will run after the previous element, unless the element has a valid before constraint. So we can add our implicit constraints and then finally graph out our elements like that. Just to run through it, each node has multiple connections, and these will be our node children. Init 0 has 2 children, init 3 and init 1. Init 2 has 1 child, init 1, and then all the other nodes have no children. With our objects graphed, we can iterate through them, starting with init 0, and then init 3, but because init 2 needs to run before init 3, we'll return init 2 next as a sort, and then init 3 comes next, and then finally init 1 at the end. So the resolve sorted order is 0, 2, 3, 1. You can test this in a Rails application yourself. The result will be the same. On an application with about 2,000 initializers, this takes about 750 milliseconds to t-sort each child and not many other clues, unfortunately. So maybe the sort itself is taking the vast majority of time here. But why is that? Well, if you think about it, 2,000 nodes times 2,000 iterations of children is like 4 million iterations, and that's a lot of redundant array scanning, in my opinion. The select here is the problem, unfortunately, and it iterates the entire collection array for each node, and there's probably a better way to do this. Instead, we can change the implementation of collection like this. We add a order and resolve hashes and a collection array like we had before. The order hash keeps track of names, while the collection and resolve data structures keep track of the initializers themselves. Now, when adding initializers, we have to do something a little bit more fancy. We start by adding to our collection array like we did before, and then mapping the constraint to the order hash, so telling Rails if the initializer is running before or after another initializer, and then finally adding the initializer to the resolve hash. And we're using the resolve hash because an initializer name is not guaranteed to be unique, so multiple initializers can have the same name. And this implementation makes that a little bit more obvious. So this makes iteration much easier. We're still iterating each node in the main collection like we did before to preserve the insort order. And then each child is simply looked up in these hashes. We did the complicated sorting work upon insertion, so that would eliminate the redundant scanning we were doing in the previous implementation. Profiling this again, the tsort each child sections are absent. And so we made this quite a bit faster, which is nice. And it's one of those rare times where we're still doing the same amount of work, but just in a smarter way. You can read more about faster initializer t-sorting in this PR on Rails 53615. Better initializer sorting, unfortunately, is not released yet, but it will be in Rails 8.1. Now, I talked about quite a lot here, so I'll do a quick recap and talk about why this all matters. You can and should profile boot time of your application. You might be able to find and fix a few performance regressions along the way. Translations are watched during development of Rails applications, and this process is a lot faster in Rails 8. Routes are lazily loaded locally in Rails 8, and this saves us a lot of time during boot of our application and development. And initializer sorting will be much faster soon in Rails 8.1. Through these optimizations and a little bit more work, we were able to bring the Shopify monolith boot time down from about 12.5 seconds to about 4. And as of this week, it is closer to about 3.5 seconds. Thank you. We can see specifically that the watcher setup here and the route drawing areas are significantly reduced. And because so much of this work was done on Rails out in the open, your application should be faster too. all you need to do is upgrade. Thank you. So we have about 5 minutes left for questions. If anyone has any questions. Things that are slow, good question. What is left on my to-do list for things that are slow in the application? I think so. I talked about 2 areas here. Rails initializing is probably the area that I would say is in a very good place. The other area where we're loading application gems, it's quite a lot more complicated because you have, especially an application with a lot of dependencies. We're in pretty good standing there, but I find that because we have so many dependencies, there's more leaks that happen or more performance regressions that happen in that area because there's a lot of code that we don't write ourselves. And not necessarily from other people, but even from other teams at Shopify. So it's a little bit harder to wrangle sometimes. I would also say that, Rails initialization is trickier for other reasons, mainly because of load hooks, and sometimes people load a constant too early, for example, and then that chain loads a bunch of other things in your application. So that's another thing to watch out for as well. Any other questions?
I was wondering how are you going to keep it this way? Like over time, do you guys like set up some sort of ratchet or some monitoring so that like it kind of stays good as the application continues to grow and evolve?
Yeah, that's a great question. So how are we going to maintain order in the chaos of a large application where thousands of developers are working on it every day, right? That's a good question. I would say we have some checks in CI to make sure that load hooks are not loaded too early. So you can add like a load hook that prepends to say like active record is not, or active record base isn't loaded, and if it is, then raise. That's one thing that we've done that will do an early, give you early feedback in CI, or you can run the script locally. I think that's helped us quite a lot. But in terms of like letting a dependency through, you can add a very complicated script that does that with like checking if constants are defined and stuff too, but it's kind of an uphill battle. So regularly profiling your application or even automating that to have a robot do that for you, I think that would be a good way of doing it. And then just taking a look at that, weekly, monthly, however you can handle that. Does that make sense? Thank you. Yeah. Any other questions?
Yeah. Applications that use Rails engines a lot, does that multiply this problem?
So engines are like tiny applications, sure. I would say depending on how you're sourcing them, like in Shopify, we use a lot of engines that are like local to our application. So it's kind of like the blast radius would be the same if we just had like a gigantic singular application. But again, if you have like a lot of dependencies that exist in other areas of that are like on Ruby gems or like are external to your Rails root, basically to your singular application, then yeah, like it's the same problem as introducing upgrading a gem and all of a sudden that having like a performance problem, right? So yeah, depending on where your engines are sourced and who's writing that code, it can be more complicated for sure.
Hey, Gannon, thanks.
Hi. Thank you.
I'm wondering, is there any reason that you can't apply these changes like Rails 7 or 6X?
You're going to have to talk to the Rails core team about the maintenance policy, unfortunately. I can't field that question. That's fair. I appreciate that.
That's fair.
Thank you. Okay. Well, no more questions. Feel free to stop by the Shopify booth. I'll be there intermittently throughout the conference, or if you catch me in the hallway, please say hi. Thank you so much.